Hello and welcome to the second tutorial video for rtpengine. This will be a pretty brief video and I will show you how to simulate signaling to rtpengine. This is useful for troubleshooting purposes, debugging, or just if you're curious to see what it does with the various options that you can give it. I will be doing this on a Raspberry Pi. I have rtpengine installed from Debian packages, and rtpengine is running on the Raspberry Pi locally here. And what I will be using to simulate the signaling to rtpengine is a script that's included with rtpengine in the packages, called rtpengine-ng-client. This is a very simple, very basic script. In fact, it's so basic that it doesn't even have an online help. And if you call it without any argument, it will just die on you. But it's easy to use, and easy to use especially once you get the hang of it. It basically takes one mandatory argument, which is the command you give to rtpengine. In the simplest case, this is just ping. And you will see rtpengine responds back with a pong here. And the usual other commands you can give are like offer, answer, and that kind of stuff. And for other options, you can look into the script itself. It's a Perl script. All the options are listed here at the beginning. If you're familiar with rtpengine a little bit, you will recognize some of these. These are all of the usual options you can give to rtpengine from, say, a Camilo script. Some of them are named a little bit different, but most of them are verbatim exactly the same. And what we will do to demonstrate this, I have a log file here from rtpengine produced, and if you have debug logging enabled, you will see this kind of dump for any command that's given to rtpengine. In this case, this was command offer here. And we will use this to try to recreate this and simulate to rtpengine, and then see what happens if you play around with the various options. For verification purposes, I will start tailing the log file here. And the first thing for almost any interesting command anyway is you need the SDP body. And you can copy this out of the log file here. You obviously have to remove the lead in and the lead out of each individual log line. I have this prepared here, and you put it in a file. So you basically have just a file with just an SDP in it. Another way you can get an SDP to play with is, for example, if you have a Wireshark with zip traffic captured, you can just pick on an invite here, and you will see there is the SDP in Wireshark. And what you could do, for example, is you just click on the SDP, you say copy as printable text, and then you can open an editor, just paste it in, and then save that to a file, and that should work. So back to our example here. So I will take this SDP, which I have copied from the log file, and I will call the ng-client script. I will give the same command, which is an offer. I need to tell it where to take the SDP from. So I say sdp-file is this file that I made. And then I will pick some of the options here that I think are relevant. You can pick any or none options and then just play around with it and see what happens. The minimum you will need is a call ID. What I generally like to do is use a random call ID, and the way I usually do this is I put it in the shell and I just say give me a random call ID, and then I will use this here as the call ID. And because this is an offer, you will also need a from tag. You can just use anything you want. If you want to be really specific, you can obviously copy it out of the log file, the one you want to debug or troubleshoot or whatever. And I can just do this for now. And you see here in the log file, RTP engine has received the offer, it replied to it, and it is returning a new SDP to me. And in the log file, if you have the debugging enabled, you will see it afterwards. It will tell you response, dump to offer, and this is the output. And so in general, if you give the same options as you used previously, you should get the same output, maybe with different ports, but in general, you get the same output. And the things you can do with this now is, for example, you can give it a different transport protocol, because the input now is rtp-avp, this is plain text RTP, and you can say you want to translate this to SAVP, which is SRTP, and you do this again, and now you get a different SDP output. And in this case, this is SAVP, the one I wanted. Then you see all these ciphers that are added, and then at the end, this is the DTLS. And then you can keep going from there. For example, you can say SDS off, you do this again, SDSS disappears, and you're only left with DTLS. Or you can say DTLS off, and then you get the opposite effect. And this is what you can use to kind of play around with the options. And you should just look at the script itself to see what options there are. Like I said, it should be all of them that RTP engine supports. Occasionally I forget to add one, and then it would be missing in the script. But that's an easy fix, and just add it to the script and then it should work. And common options that are usually for troubleshooting is things like codec-transcode. Let's say you want to add transcoding options. Actually, let me remove the SRTP here, just do the transcoding alone. And then you can see as you add options, let's say we'd want to transcode to G722, then this gets added to the output SDP, and so on. So this is what you can do, what you play around with it. And then if you want to be more sophisticated in your simulations, you can also add an answer and then see what comes back out for the answer. You obviously would need the same quality. You would have to pick a 2 tag, yeah, and so on. And you can pick any of these options. So if you want to continue this, for example, if let's say you want to translate this to a WebRTC SDP, because the input here, this is just plain text soft phone RTP. So what you would want is the protocol is SAVPF, that's the one you want. You don't want SDS because WebRTC disallows that. You can add rtcp-mux require, because that's another thing that WebRTC requires. And then you can say you want to transcode to opus. And then what's coming out of here should be pretty workable for WebRTC. So this is the things you can do. If you're a developer, you can look in the script. It's a Perl script. It's using a Perl module that is also included in the package. And this is very simple here. You just create an instance, a new object, give the address, the listening port of rtpengine, and then you add the request. And this is basically, it reflects the options that you see here. So it would have an SDP key and you would have all these keys, and then the library takes care of doing the actual request. One option that is, two options that are slightly different, that are not actual options that are sent to rtpengine. That's those two: proxy address, proxy port. This allows you to talk to a rtpengine that is running on a remote machine. For example, I can start it up on my local machine here. I'm gonna need a address first, 0.87. So I'm gonna start this up on my local machine here. And then you can say proxy. Now proxy refers to the RTP proxy, not like a SIP proxy. And then you just give it a different address. And as you can see, this has now been talking to my rtpengine running locally here. If you don't have rtpengine installed from a Debian package and you just have the Git tree checked out for development, or you compiled it locally, whatever, the script is included in the utils directory here. You should be able to launch it, except that you're not gonna have the Perl module installed. And the way to use it from the Git tree directly is by telling Perl where to find the module. So you just need to tell Perl the include path, and then the script works. It's right now I don't have rtpengine running, so it just tells me connection refused. One more way to play with rtpengine signaling is a relatively new feature that we have, which is that we support JSON format directly. And to use this, we don't have a, well, we do have a tool. You can use the same rtpengine-ng-client if you give the JSON option. It's using JSON format internally. There's no visible difference, so that's not very useful, but this is useful if you want to make your own script, whatever, that talks to rtpengine. And you can simulate this with, let's say, a netcat. You just go to I think this is the port, if I'm not mistaken. And the format is, you need some kind of random cookie, and then you just write a JSON document. You say command ping, that's the most simple one. You send that off, and you see you get the response back from rtpengine, in this case the Pong. And that's it. This is how you can play with rtpengine signaling to troubleshoot, to debug, to see what it does with various options. And I hope this is useful to you.